Okay, sorry. My friend just phoned me to tell me that one of our other friends is having a baby today. She finally went into labor. Okay. So I'm super excited now, and I can't remember where I was, but I think we just started with the topic of friction, so here we go. Focus your mind. Good. Friction is a force that acts when two surfaces rub together, like we just did with our hands. Some materials cause more friction than others. Rub your hands together. Feel them rubbing and getting warm. We already did this. When hands are rubbed together, friction acts between them. It's because your hands aren't smooth surfaces. They are things that stick. So the more that you rub, the harder your hands has to work. And that's why it's getting warm, because the force is being exerted. You can go very fast down a slide. There will be friction between your clothes and the surface of the slide. So if you are wearing clothes that are going to kind of stick to the surface of the slide, you will go slower. And if you are wearing smooth clothes, you will go faster. Friction can start and stop things moving. You need the friction between the floor and your shoes to help you start walking. It's kind of that pulling away thing. So if this is the floor, you don't just do this. You step and then you push away from the floor to lift up your foot. I literally just scratched myself. Sorry, I have an itch now. To lift your foot from the floor and go to the next spot. There's friction between the bottom of your shoes and the floor, which helps your shoes to grip the floor surface. And this stops you from sliding. That is why almost all shoes, actually I think all shoes, are mainly rubber at the bottom, because rubber is a very good material to induce force, to induce friction, to make sure that the friction of your shoe works nicely on the floor so that you can walk. Ice is slippery. There's little friction between the puck and the ice, and so the puck slides easily when it's hit by the player stick. The ice is slippery and the puck is smooth. That's why when they hit it on the ice, it literally just goes and it doesn't even stop at all. No, a tiny bit. If you roll something across the surface, friction will cause it to slow down. Right, that is how a ball stops. When you are kicking a ball, it doesn't just keep going forever. It stops at a certain point. And it stops at that point because friction has made it stop eventually. The rubbing of the floor and the ball and those two materials together make the ball eventually stop at a certain point. Good. The friction between the ball and the bat helps the ball to change direction. You guys don't have this page, but I'm going to read it to you anyway. Forces and friction. You can use a force meter to find out about friction. If there's more friction, you will need a bigger force to make something move. So the more friction there is, so friction is basically almost resistance. It's the two materials working together to kind of try and slow down the movement. So the more friction that there is, the harder you are going to have to pull, so the bigger force you will be using. Okay, here they say you have to plan an investigation, but we unfortunately cannot do that. So, questions. When does friction act? Well, when two surfaces meet. I don't really know when two surfaces rub together. Okay, so when does friction act? When two surfaces rub together. So my finger and this page, the pen and the page, the pen and the table, any two surfaces. Faye loves her garden slide. She finds that when she wears cotton clothes, she goes faster than when she wears woolen clothes. Explain why. It's because cotton clothes are made to be more flat and smoother than woolen clothes, which are bumpy and maybe sometimes a rough exterior, not texture, but surface, which makes the friction more. Friction acts when two surfaces rub together. The size of the friction force depends on the two surfaces which are rubbing together. So the size of the force of the friction we talked about this here. You need a bigger force to pull when both surfaces kind of don't want to let the other one go. Good. All right. Now, after that, let's take a look at our worksheets. They say check your progress. Here is a ball bouncing toward Camille. How can she stop it? There is enough space on this page to write your answers, but I want you to do it neatly. So maybe for make a small line. For B, make a longer line. And then you write A and B. Quickly do that, and then we will discuss the answers together. Pause the video and get those 2 lines drawn with a ruler. Good. How can she stop this ball? She can catch it, right? And how can she change the ball's direction? Well, she can either push it away or she can throw it, which is basically just pushing it away from you. So how can she change the direction? She can push it away. You can take your time writing those, but I'm moving on. So if you want to pause, you can do that. Which force meter is measuring the greatest force? Remember, greatest, biggest. So we are looking for the biggest number. It's as simple as that. Whatever is hanging here is measuring in at 5 newtons. Whatever is hanging here is measuring in at 10 newtons. And whatever is hanging here is measuring in at 20 newtons. So which one, A, B, or curlica, which one is measuring the greatest force? You can circle that letter. Not all 3, only the one with the greatest force. Good, and then let's move on to our next page. Alex tested the force needed to pull. Where's my elastic now? I was playing with it still. Oh, there it is. Alex tested the force needed to pull his skateboard over different surfaces, and here are the results. Force in newtons, so 0 newtons, 1 newton, 2 newtons, 3 newtons, 4 newtons, 5 newtons. Just so by the way, with a force meter, the numbers going down get bigger because of this little thingamajiggy. So this, as the further this is pulled down, the further it goes down on the inside, and that is where it will be measured. Okay, but we'll still discuss that. So, on wood, he measured between 1 and 2 newtons, actually exactly a half between 1 and 2 newtons, so we can say 1 and a half. Grass, he measured exactly between 3 and 4, so that's 3 and a half. And then a stone, he measured at 1 newton. So which surface was the hardest to pull the skateboard on? Make 2 lines with your ruler. These are not going to be long answers. So which surface was the hardest to pull the skateboard on? Remember, the more newtons, that means the more force he needed, the harder he had to pull because the more friction there was. So which surface was the hardest to pull the skateboard on? Listen to what I'm saying again. I'm not going to give the answer. Listen to what I'm saying. It will be the hardest to pull the skateboard on a surface that has a lot of friction. And the more friction that there is, the harder you have to pull. The harder you pull, the higher the number of newtons, because the force will be bigger. So the bigger the force, the more the newtons. So which surface was the hardest to pull the skateboard on? I'm hoping you guys understand. But which surface was the easiest to pull the skateboard on? Let me just give you guys an example. If I were to pull a chair over tiles that had, no, not a chair. A chair is always difficult to pull. If I were to pull My trolley. You guys know my trolley that I always walk with? This one. This trolley. Okay. So if I were to pull that trolley over newly mopped tiles, the force would be very low. It would maybe measure in at 1 Newton. I actually don't know. But let's say it would measure in at 1 Newton or 2 Newtons. Because the tires of my trolley are made of rubber. So it is a bit of a resistance. But the floor is not giving me a lot of friction. So there isn't too much friction. So my force is going to be less, and therefore my newtons are going to be a small number, so 1 or 2 newtons. That means it glides over it easy. When it's hard, like let's say a carpet, like like that carpet, like that one, okay? That carpet would be hard to pull because the rubber and all of the little bumps on the carpet would work against each other and make more friction. And the more friction there is, the more force I have to pull my bandwagon, my trolley with, and that means the higher the number of newtons, so it would probably go up to 5 newtons. So 5 newtons means I had to pull really hard because the force was a lot, and 1 Newton means the force was not too bad. I could literally just easily pull my trolley. Good. Number 4. Which surface creates the most friction with a skateboard? Here you are going to have to think about it. Wood, grass, or stone? Which surface creates the most friction? Oh no, you don't have to think about it. Actually, you do. The answer is in the bar graph. Which surface creates the most friction? Remember, the more friction, the higher the number of newtons, because the bigger the force is. So which surface creates the most friction? The answer is right here. Explain your answer. Why do you think it is like that? Why do you think that this? So circle the correct one. And then to explain, I want you to draw 2 long lines with your ruler, and you can go right on them. Why is grass Okay, well, I'm not going to... Okay, so the answer is grass. Which surface creates the most friction? Is grass, because grass had the highest newtons. Okay, so with other words, it was the most difficult for him to skateboard over grass. Now you have to go tell me, why do you think that is? Why did the wheels of the skateboard and the grass make so much friction that he struggled to pull his skateboard over the grass? That is your science for today. I hope you enjoyed it.